This video will look at how to do analysis of variation, which is a method for comparing multiple averages using the TI-83 and 84 calculator, the 89, and GeoGebra. This is a two-step process. The first step is that we have to type in all the information for the three groups. In this case, I have groups Amelia, Barbara, and Cynthia. You could do this for any number of groups, 2 or more. In my TI-89, I'm going into apps. I'm going into stat list editor, and I'm typing my values in list 1, list 2, and list 3. Reminder how to type things inside of a list. I go into the list, I type in my numbers, and I hit enter thereafter. It's okay if I don't have the same number of values for each of the list. In fact, for this particular data set, scrolling down to the bottom, I notice that I have more values for Amelia than I do for Barbara and Cynthia. I don't need to have things balanced to do Anova. After I've typed in my data, I go to where I usually go to for test, which is apps, stat list editor, and then I go up to the top, F6 for test. I hit blue F6 to pull that up. And I'm scrolling to the bottom. I'm looking for Anova. Now my calculator has both Anova and Anova two-way. I'm just looking at Anova. I'm only looking at one variable here. I have each of these three individuals. If I had the summary statistics for those people, if I knew the average and standard deviation, I would choose this option and then I could type in those numbers. I actually have the raw data this time, so I'm going to choose data. And then I'll hit enter. By default, it thinks I want list 1, list 2, and list 3, and I do. That's pretty good. In the situation that I have a list showing up somewhere else, reminder, I could always use this blue and then variable link button down here to pull up all of the list. So for example, blue variable link, I could scroll through to find list 1. And I could put that down for my first list. It's already in there, but that is an option I have. When I hit enter, enter again, this gives me my F stat, or my test statistic, of 2.059. This gives me a fairly large p-value of 0.149 or so. With a p-value as large as 0.149, I would likely fail to reject a null hypothesis. The process for this, again, I type in my data. I do this in stat list editor, and then I go up to the top where it says test, and I choose to test for Anova. Now, just as a note, I left and went back to stat list editor just to kind of show you what that process looks like from scratch for that. But I don't have to leave stat list editor. I could have just hit F6 and immediately done the test without going back into apps that second time. Let me show you how to do the same thing now in your TI-84. I'm using the TI Smart View, and I'm going into stat and then edit first. The reason why I'm going into stat and then edit is I have to be able to type in my raw data. Stat edit allows me to do that. After I've typed in the numbers, which I've already done here, again, I'm just typing in the number and hitting an enter afterwards. I'm going to go to stat. I do have to hit this button this time. I'm going over to test, and I'm scrolling until I see the option for Anova. You'll notice that it just says Anova, and it's wondering, well, what do you want me to do Anova with? Well, on your TI-83 and your 84, you're going to have to tell it which list you want to analyze. So to do this, I want to analyze list 1, list 2, and list 3. That's showing up in the blue down here above the 1, 2, and 3. So I'm going to hit second and then 1 to get list 1. Comma. I'm going to hit the comma button between each of these values. Second 2, list 2. Comma. Second 3 for list 3. Once you've done all of your lists that you're analyzing with commas in between, close the parenthesis and hit enter. This will give you your f-stat, same f-stat as before, 2.059, and the same p-value, a p-value of 0.149 or so. This gives me information about factor. So this is my SS for the factor they mean treatment. So this is the SST. They gave me an MS for the factor. That's the MS for the T, or the variation between your groups. For the error, this is the SSE. This is your MSE, the mean squares for your error. Another name for the mean squares of your error, this is the variation within your group. So Anova compares variation between group and variation within groups. I'm going to show you how to do the same thing now in GeoGebra. Inside of GeoGebra, I open up the option for spreadsheet when I first go into this. And now I have to type in all of that data. And I'm just hitting enter in between. Once I get the hang of this, it's a pretty quick method. The TI-83 doesn't have a nice way to do Anova using summary statistics in the same way that TI-89 does. So this is the reason why I'm working with raw data, because it's consistent across all these technologies. I'm going to, after I type in my data, spreadsheet, type in your info, click and select the info you want to analyze. So I'm going to click and select this data that I want to analyze. And once it's all highlighted, I'm going to click the thing that looks like a histogram. Inside of this, it gives me a lot of options. I'm either looking at one variable, two variables, or multiple variables. Anova is used when I'm looking at multiple variables. I'm going to choose this option. By default, it gives me this view with these stacked box plots. So I'm going to go ahead and add to this. Right up at the top, there's a button that looks like sigma x. I'm going to hit this button that says sigma x. It's in the top right corner. And it's going to give me the summary statistics down there at the bottom of my screen. If I didn't want the mean and the standard deviation for each of my groups, although that's really helpful to have the mean and standard deviation for each of the groups, I can go down to the bottom and I can choose the option for Anova. This will give me the MS between, the variation between groups, and the MS within, the variation within. MS means variation within the means of the squares of both the treatment and the errors. I have my F ratio, I have my p-value. I can quickly come up with my conclusion of my hypothesis test based off this information.